got a little reminder for you. The derivative of displacement is velocity. The derivative of velocity is acceleration. But now you know that you can work backwards with integrals. So the integral of acceleration is velocity. The integral of velocity is displacement. Good to know. Okay, the displacement of a particle is the integral of velocity. Okay, well, let's just write that. So the integral of velocity is going to tell me equals dt. Does not. That's the worst notation ever. I would start the video over, but I just don't have the heart to. There we go. I'm embarrassed by what just took place. But it would be that right there. But here's where things get a little tricky. And we need to consider this. My velocity might be some graph where we've done this in a lesson before, where we have, so here's my velocity on some interval from 0 to 10 or whatever. My velocity, I'm moving forward, I'm moving backward, moving forward. And so if I want to find out my displacement, all my forward minus this distance here, that would be represented that way technically with a negative. So positive, negative, positive, it would tell me how far I went. So if I started at some location, forward, minus, or negative, and then forward again, I would have some displacement from where I started. However, if I want to know the total distance I traveled, speaking of travel, you probably hear the floor buffer out there. So the total distance this guy is traveling, let's turn it into a word problem. Every time this guy that is buffing the floor outside walks forward, it counts as positive. Every time he walks backward, it counts as negative, but we don't want it to count as negative. So let's suppose that, this is great, I'm glad the guy's walking by. Let's suppose that this is a starting point, and he goes forward, and then he goes backwards, and then he goes forwards, and then he goes backwards, and then he goes forward, and he ends up back where he started. And when he does, you can probably hear it. When he does, it looks like he didn't go anywhere, but the fact is all his positives and all his negatives canceled each other out. And so the total distance he traveled isn't just the velocity, dt, don't put equals dt, that would just be tragic. I need all my negatives to count as positive as well. And so sometimes in a situation like that, if we had this graph, if we had to do this by hand, we would find this area, this area, this area, make this one positive, and then add them all together. We'd have to break it up into pieces in separate intervals. Okay, the position of a particle, this is going to be kind of neat. If I know how far I went, my displacement, if I said, oh, my displacement is -5, that means I'm 5 to the left of where I started, or 5 down from wherever, down, left, x-axis, y-axis, whatever the relationship is. So this is the floor buffer. This is my displacement. They look alike so far. However, if I can tell you how far I am from where I started, positive or negative, and can also tell you where I started, then I can tell you where I finish. If I said, you know what, I'm 5 feet ahead of where I was, and then you're like, well, where did you start? Well, I started at this chair. Well, then I can measure 5 feet from that chair and I'll be good. So S of A plus that. What is S of A? Okay. S is what we often use for displacement. So let's grab the purple pen. You've rested long enough, sir. Good day to you, sir. So this guy right here is going to be the position of the particle at a specific time, and that time is at A being the beginning of our interval. So we begin at a specific place. You couldn't see my fist, but on the other hand, I was going, rawr. So we begin, and then we move around. So I have a starting point, and then I have some motion. Starting point plus the complete displacement, positive, negative, whatever it is, will tell me where I am.